Hello everybody, so today I will talk about the calculus. The topic today is about the radian and directional derivative. So I will show you the step by step in each homework and the question. Question number 1, if function s, y, z and we have the function like this, then the radians is we have def the function f. So in here we have the formula. That's why we have function. We do first derivative of the function in here of s, and then later that's about y. Later that we have z in here, and everything is about function. I put like this. Now first derivative of the function respect to the s. So s right now will become the variable in here, so that this one will become e power 4y and psi a z in here. First derivative of the function respect to y, so y become the variable in here, so e power 4y in here, that will become to 4s e power 4y and psi a z, so that everything near to y and z in the s, they will become the number. If they add the y, so s and z, they will become the number. So the last one, first derivative of the function respect to the z. Z now become the variable, so s and y, they will become the number. First derivative of psi, they will change to cosine, and we have number a put outside, and you got about a s e power 4y, and this become to cosine a z in here. So this is the first question. The next question we will talk about directional derivative. We have the function and we have the unit vector is about 3 to 5, and directional derivative at the point -2, and 4. First we will do two things. First we need to find the magnitude of this vector in here. So we have unit vector is about, we have 3, 2 and 5 we put on the top, then we put about 3 power 2 plus 2 power 2 plus 5 power 2. 3 power 2 is about 9, 9 with 4 is about 13, 13 with the 25, you got about 38. So I need to check. So in here we got about 3 over square root 38, 2 to the square root 38, and 5 over the square root 38 in here. So this is the first step. The second one, that's about the function. We need to find the radian of the function. So we have 2sy and z power 2. Now we do s, so s is become the variable, y and z, they will become the number, so that we have 2y only. Now we do y, so s and z, they will become the number, so you got about 2s. Z, they will become the number, and this one z become the variable, s and y become the number, so that we got about 2z in here. So we have this one, we multiply in here, So we put about du with the function. We have 3 and the square root 38. That's about related to the number, so we multiply in here. So s with s, y with y, and z with z, so that we have 6 square root of 38 y plus 4 square root of 38 s plus we have 10 square root 38 of the z in here. So now we have the point is about minus 2, and 4. And we have minus 2, and we have 4 in here. So now we just input the number in here. So that we just calculate everything. And you go about 20 over square root 38. So this is the answer. The next one, the question they ask about the direction of maximum rate of change of function. First, we need to find the radian of the function by the first derivative in here. First derivative of the s, so you got about 3y. First derivative of y, you got about 3s. First derivative of z, you got about 2z. And we have minus 5, minus 1, minus 3. You change, if this is about s, y, and z. So y is become the minus 1. 3 multiplied with minus 1, you got about minus 3. With the s, that's about 3 multiplied with minus 5, you got about minus 15. 2 multiplied with minus 3, you got about minus 6. Then we put the square root and with the power 2 in the each number in here, and we got about the answer. That's about 3 multiplied with square root 33. That's it, the end. Thank you for watching.